right? So let me draw a little picture over here, and then we'll get started with this class. So let me draw a set of axes. This is horizontal axis is the x-axis. The vertical axis is the y-axis. Let me draw a graph. So why don't I have my graph look like this? Okay. And then let me label some stuff here. So I am going to want to have a dotted line. So I'll have a dotted line going like this. There's one. I'll have one go like this. Here's another. I'll have one go like this. And I'll have one go like this. Okay. And I want to talk about this picture. I want to label this a little bit. So we'll call this part here A, and this letter here B, and this bottom letter here C, and this letter here D. Okay. This picture kind of represents a function. So we're going to call our function y is equal to f of x. And that's really described by that blue curve there. All right. So we're starting to learn a little bit about calculus. And I guess normally I would motivate the idea of calculus on the first day. But I'm basically going to tell you straight up, calculus doesn't start until chapter 2. So we're going to do sections 1.1, 1.2, and 1.3. And this should be review for you. But just because it's review doesn't mean that it's not important, because basically we perform calculus on functions. So we really want to learn, I guess, functions in a very systematic way. Okay, so the first thing we want to do is we want to talk about what a function is, what the definition of a function is. And a function is a rule that assigns to each, or let's say not to each, let's say to every input value from a set D exactly one output value. Okay, so that's going to be what our definition is for a function. And I want to highlight a couple of parts for you. So the first part I want to highlight is this idea that it's a rule. In other words, when I say a rule, I mean there's some method of assigning input values to output values. Some sort of rule. Sometimes it's a formula, sometimes it's a table, sometimes it's a description in words, but they need some way of communicating where the input value goes, right? The second condition is that we really need this idea that it only assigns exactly one output value. Okay, so this exactly one is also kind of important. So, so does anyone know what this set D would be called? Because it gets like a special name. It's not coincidence, it's named D.
Domain.
That's right, sir, domain. So the domain is the set of all input values. Okay, and the range is going to be the set of all output values. Right? So if you were to look at the example that I've drawn in this little picture on the side over here, what is the domain? What would you guys say the domain is? Any thoughts?
Wouldn't be A and B, would it? Or no?
A and B. So do you mean just the points A and just the point B, or do you mean all the points that are sort of in between as well?
Yeah, so the x-axis, right?
Okay. So now you've said something a little bit different. I like what you're saying, but you said something a little bit different. First, you said AB.
Oh,
Then you said the x-axis.
Yeah. Narrow it down to in between A and B.
Oh, in between A and B. Okay. So I like that. I guess my question for you is, are we including A and are we including B or not? Or you can't tell? What do you guys think? Maybe it's not obvious. So why don't we use this opportunity? Let's investigate. So what I'm going to do is, where the A is, I'm going to put a little open circle like this. And where the B is, I'm going to put a little closed dot like this. So this obvious, or I hope you realize that this means two separate things, right? So we do mean all the X values in between A and B. The open circle is going to mean we don't want to include the point. And the closed circle means we do want to include the point. So one way that we could write it is we could write it like this. We could say X values are going to be between A, but because we don't want to include A, we're going to put a little, a less than symbol. And then I want to go all the way up to B, but this time I do want to include B. So if I want to include B, then I'm going to put a less than or equal symbol. Does that make sense? So this notation describes our set. And this notation is actually called, I call this inequality notation. And the reason why it's called inequality notation is because these two symbols here, these are called inequalities. So this is technically a compound inequality because it has two inequalities within it. Is there any questions about that? So another one I want to look at is actually I want to look at interval notation. Can you guys all, here's what we'll do, okay? So I want you to go to the chat box. I want you to type your answer for what is the interval notation in the chat box. I don't want you to hit enter yet. So for instance, I'm gonna come over here. I'm gonna say to everyone, I'm gonna say my answer would be, I'm gonna type my answer. The question is, let me write the question so you know. How do I express the domain in interval notation? That's the question. So what you're gonna do is you're gonna type your answer in the chat box. I'm typing mine, but don't hit enter yet. And then I'll tell you when to hit enter. And then you guys can hit enter and we'll see if we all get the same answer. Are you ready? On your marks, get set, enter. All right, let's see. Oh, we got a lot of good ones. Got a lot of good ones. Right. Okay, cool. So based on my responses, based on the responses I see here, almost everyone gets the first part correct. So the first part I think is this, you have a round bracket for A. Round bracket means we don't include the number. And then we put a comma to indicate that we have an interval. So we want to include all the numbers starting at A and ending at B. And then the brackets tell us if we want to include it or not. And if I want to include the B, I put the square bracket. If I don't want to include the A, I put a round bracket. So I think this would be the correct answer. Is there any questions about that? All right, good. So move this like this. So the range is going to be the set of all the output values. So why don't we all write the range? Well, you probably could tell what the range is, right? So when we're talking about the range, that lives out, the range is like all the Y values. Those are all the output values. So Y is going to be between C and D. This time, both C and D are included. So then when I go to write the interval notation for this, it's going to be this square bracket A, B, close bracket. Okay. And in case it wasn't obvious, I wanted to make it totally obvious. The reason why we're talking about functions is that these are the main mathematical objects that we work with in calculus. So all this seems pretty basic, I hope. Most it almost seems like every math class begins with this idea of what is a function and what is not a function. So this one is no different. So we want input, we want to know what the independent variable is. And this is really like the input variable. So most often this is the X variable. And then the dependent variable is the output variable. And this is usually Y. But this is not always the case. So this is going to change around. And we're going to look at some problems where, oh, you have to kind of turn your head sideways like this. And we're going to pretend that Y is the independent variable and X is the dependent variable. Okay. And in case it's not obvious, the output depends on what the input is. That's why we call it the dependent variable. Does that make sense? So I guess I should say it depends on the independent variable. So let me move this. This guy depends on the input variable. Okay. All right. So one of the things that you'll learn is that whenever you're trying to learn a new field, you're trying to learn about finance, you're trying to learn about cooking, or you're trying to learn about whatever, a lot of times there's this whole language factor that is involved. And, when we say, so I remember when I was a student, they would say these things and I wouldn't be 100% sure what they were talking about, but they kept using the same words over and over again. So I don't want that to happen for us. So if something is not obvious, I'm going to try to define it. So when we say evaluating a function at a point A, what do you think that means to evaluate it? Oh, whoops, it is CD, my bad. Sorry, Samantha, I didn't see your comment till just now. You could also just say something out loud. Yeah, that's CD, Samantha and Catherine. Okay, the range there. So evaluating a function at a point A just means plug A into the function. Plug X equal to A into the function. Right, so when we say evaluate at A, that's basically f of A. Okay. So if I say, for example, for this function, evaluate f of 2, all that means is anywhere you see an A, you plug in a 2. So anywhere you see an X, you plug in a 2. So we're good. This is basically going to be 2 squared minus 2 times 2 plus 3. It's going to be 4 minus 4 plus 3 is 3. Does that make sense? All right. So try to do my notes in black, the examples in blue, and the comments in red. I try to do that. We'll see how well it goes. Okay. So if you look at this next guy, if you look at this one right here, students in general are they have no problems plugging in actual numbers, but somehow when you have to plug in variables, this makes students a little bit uncomfortable. Just think of these variables as a number. So it's the same thing as what we had before. Anytime you see an X, you just plug in A plus H. So in this particular case, it's gonna look like A plus H squared minus 2 times A plus H plus 3. Okay. So why don't we simplify this a little bit? I don't know how much to review, but this idea that there's this idea about foiling. You first outside, inside, last. It's an algebra idea. And then you also have special formulas, like there's some that are like X plus Y squared. This happens so commonly that people almost remember how those distributions work. So that's like, X squared plus 2XY plus Y squared, right? That's just true in general. So we could apply that with our A and our H. So if we were to work on this guy, this would be A squared plus 2AH plus H squared minus. And then for this second part right here, you need to distribute, right? You have to use that distributive property. So that's going to be minus 2A minus 2H plus 3, like that. So one thing I want to draw your attention to is you see this negative right here. A lot of times students forget to distribute the negative to both terms when they're doing the distribution. So just make sure you don't forget that. So I normally on the first day, I do this error analysis kind of group work, which we probably should have done. But I just let you do it at home. It's just a lot of common algebra errors and trig errors that students make that you see all the time. I see all the time, and they make it in 5A. So I hope that by exposing it to you early on, you won't make those errors. Okay, that's my thought at least. So is there any questions about either of these? I hope this is pretty straightforward.